So go ahead and open up to page 11. We're going to talk about a couple of things today. On Friday, we had started looking at this chapter 8 and kind of talking about how to graph the items and such. And so we practiced graphing them. And so now we're going to do more with this information than just graphing it. Okay, so here was page 10. And so let's review. On the bottom of page 10, we had talked about this problem, which was about professional degrees that were awarded to women in the 1973-1974 time period, and seeing if that then could predict what was going to be happening in 78, 79. Okay? So that's kind of ultimately what we were trying to do. Take these. Now these are what actually occurred. Okay? So what is in this chart is what actually occurred. And so then we put that into our calculator, and we had gotten the equation of the line, and the equation of the line was that the predicted degrees in 78, 79, I think it's percent, equaled 1.72 times the degrees, the percent of the degrees in 73, 74 plus 7. Oops. Okay, so that was what you had computed on Friday. All right, so that's our prediction equation. So we're going to use that today. So let's take a look at what we had done on Friday as far as graphing that data. We had learned how to put this into our calculator. And so we had this graphed over here on the left, our actual data. And that was our list 1 and our list 2. And then we had graphed the residuals, okay, over here on the right. So this first thing says determine the LSRL and draw it, which the LSRL is the line of best fits. That stands for least squares regression line. Okay, and I'm going to write it again real quick without the context. Predicted Y was 1.72 times X plus 7. Okay, so there it is without context. But the first thing that I want to talk to you guys about is why this is called a least squares regression line. You actually do need to know why it's called this thing called least squares regression line. And so we're going to have a little contest in class to figure that out. It'll be boys against the girls, and the winning gender gets a stamp. Okay, and there is a possibility if you both get it perfectly right, then everybody gets a stamp, so that's good. So we could all be winners here. But I have this site to demonstrate that, okay? So here it is. All right, so first of all, we've got a set of data points, and I'm going to take this line of best fits, and I'm going to attempt to put it in here where I think it looks like it fits the data well. Okay? All right, so there's my guess. Now, here is where this term least squares regression lines come from, and here's how this actually, the calculator and how you actually determine where this line goes is this process right here. You first look at the residuals. So I'm going to hit this button that says show residuals, and you see there's those residuals. We have some above, some below. Now that I see those, I probably would change this a little bit, because what happens with the positive residuals and these negative residuals? They should sum to 0. Okay? So they should sum to 0. So I reevaluated it. I thought I had too much information on too much residuals on top, so I did that. All right. Now, since those sum to 0, and that doesn't give us very good information, then, because it's kind of like when we did standard deviation. Remember, saying the people above and the people below, you add them together, that's 0, so that doesn't give us very good information on the average distance. So what did we do when we did standard deviation to fix that problem? Good, we squared. So we're going to square those residuals. Okay, there they are. So those are the squared residuals. So I have all of these areas of the squared residuals, and now the goal is to find the placement of the line so that these squared residuals is the smallest sum. So I'm going to show you the sum, and this one says 245. So I'm now going to play around with this line until I see this sum is the smallest value I think I can get. So watch when I move this line what happens. Okay, going down. Okay. Oh, 34. I'm going to go to the other end. Let's see if I can get it to go any low. Oops, look at there, going into the 20s. I saw 24. Okay, and then I'm going to come over here. See if I can go any lower than 2. Oh, look at there. Now we got 221. Up. 221. Try over here. And so on. Okay. And so then when I think it is where it has given me the smallest sum of the squared residuals. That's the key. Smallest sum of the squared residuals. And if I could write on that board over that, I would, but I don't have that feature on right now. Then I would. So I'm going to press this thing called LS line, and if when I press this button the sum doesn't move, then I won and I actually had the smallest sum. If it changes, then I didn't. Oh, it went down to 220. Okay, so I was 1 off. All right, I hadn't played with it enough. So I was 1 away from what really was the smallest sum of the squared residuals, and so that's the goal. So what I'm going to do is have a person from each team come up so we'll have one team first, and you get new sets of points, and then you're going to put this where you think it goes, and so on, and find your smallest sum of the squared residuals with the help of your people, and we'll see how far away you get from the actual smallest sum of the squared residuals. All right. All right. So in summary, that was why it was called the least squares regression line, because it was the smallest sum of the squared residuals, okay? So we did the smallest sum of those squared residuals. All right. So there you go. So that is one thing as to why it's called an LSRL. So when I say LSRL in your calculator, that's when you do that stat calc number 4 linear regression. Okay, that's the equation of the line of best fits. Okay, moving on. So the first question is find the residual for optometry. Okay, so let's recall, how do you calculate a residual? Residual RAP, R-A-P, residual R equals A minus P. So actual minus predicted. Word is right. So actual minus predicted. Now I'm actually going to write this a little bit differently. I'm going to write it as Y minus Y hat. See, that's the actual Y minus the predicted Y. Okay. So let's see here. What do you think they're talking about for optometry? Where can I get that information? Okay, let's go over here on this other page, down here at the bottom. Let's go find optometry. Okay, so there's optometry. I have an X value of 4.2. So in 73-74, 4.2% of the data points went to women. And what actually, so this is actually occurred in 78-79, was 13% then going towards women. Okay. All right, so that's information we know. So let's come on over here and write that down. We know that X is 4.2 and Y is 13. So what else do we need to know to compute a residual besides that actual Y value? Good. We need to get this predicted Y value. Any ideas how we can get a predicted Y value? Plug it in to the prediction equation. Would y'all Y'all remember those plug-it-in commercials? Because these, soon enough, it'll be out of that generation, and y'all won't, my students won't remember that commercial anymore. But anyway, so predicted Y is our equation, which is 1.72 times what? What goes in here?
4.22.
Okay, good. Our X value at that point plus 7, and that is 14.22. So 13 is what occurred, but 14.22 was predicted to occur. So what does that make my residual? Negative 1.22. So what I actually had was below what was predicted. Okay? And if I look at that up here on this point, this data area, that's here. At 4.22, what actually occurred was negative 1.22. So this residual was negative 1.22. Okay? Now, but before I move on to the next question, I want to ask you this, okay? Listen to carefully how I word this. Does this prediction line overestimate or underestimate what actually occurred? I'll say it again. Does the prediction line, does the model overestimate or underestimate what actually occurred? Oh, man, that's about 50-50. The line is over what actually occurred, so the equation overestimated, because the equation was 14.22. What actually happened was 13. So the model overestimated what actually occurred. Okay? Because 14.22 was above. So the model overpredicted. So we'll write that here. The model over-predicted what actually occurred. All right, let's move on to the next one. Find the residual for veterinarian medicine. What is its value? So this is the same process. I'm going to let you try that right now on your own. You'll get your information on the previous page and go for it. Okay, so we have 26.26 was predicted. So our residual is 2.64. Okay, so let's look at where that is up here on the picture. So let's say that that is right here. I'm not positive that that's it, but so let's say that. So my question is, my next question, does the model overpredict or underpredict what actually happened? Under. Yes, now we've got it. So the model underpredicts what actually happened. And so, in fact, that is the next question. So it underpredicts what actually happened. All right. Okay, so let's try one more of these, and then I'm going to let you try it, and then we'll go on to the assignment. So here we go. If the degrees for astronomy in 1973-74 for women was 7.8%, okay, so what value is that? Is that X, Y, or Y hat? predicted y? Okay, our 1973-74 information is your x value. Okay, so our x value is our 7.8. Okay, and the residual value in 78-79 is 5.6. Oh, interesting. So here they're giving us the residual. Huh, okay. So the residual is y minus y hat, and that is 5.6. Okay. What is the actual percent for astronomy? So they want to know actual y value. All right, so I'm going to come on over here and let's look. Is astronomy on here? Okay. So astronomy is not on here. I guess then they're expecting me to use the pattern established by these degrees and apply it to another degree. Okay. So that's what I'm going to do. I'm going to try to predict another degree from the other information. Okay. So, how do you think I can get that? Ah, nice. I do have the ability to get this y hat. Okay, we have the information to be able to get our y hat, and we're going to do that by plugging x in to our prediction equation. And that equals whatever. Somebody get that already?
20.41.
So 20.42. Okay. All right. So that means y minus 20.42 equals 5.6. Okay, so the actual y minus that predicted value equals 5.6. So now algebra, what you can do to get y. So add it over, and that answer is 20, I think it's 26.26.
26.02.
Oh, 26.02? Yeah, okay, got it. 26.02. So that is what was in, that's what actually occurred. All right. So let me let you try one more of these on your own. Let's try this one with the negative residual. Come down here and try this one with the piano performance degree and see how you do on that. Okay, so 19.91, or no, 19.11, okay? All right. Okay, so that's how you work through using those equations, using what you have, using what you don't have, kind of going all the way through those different items. So let's go on to the next page of your notes. This lesson on what happens if a linear model is not appropriate, we're going to talk about that tomorrow. We're saving that for tomorrow, and today, your assignment, I'm going to have you do pages 13 and 14 only because it's Halloween, and I think you can do a lot of this in 30 minutes, if not all of it. But listen up, I want to give you some heads up on here before we get started. So let's take a look at this problem on page 13. Here we go. So this data is a study of ice cream consumption, and it spans springs and summers for 3 years. So they have information on the ice cream consumption in pints, because later it'll talk about gallons, family income of the consumers, and then in $1,000 per year, and temperature in degrees Fahrenheit. So you have to be careful on what is the explanatory variable on these. So in part A it says, create a graph of the income as the explanatory variable. So that means this is your X variable and consumption as your Y. All right, so that means be careful with what you are putting in to your equations, L1 and L2. All right, and so then here, so you got make sure you do your labeling correctly. This is your consumption, this is your income. Okay, this next one says, create a graph of the residuals. Okay, so I'll walk around helping you guys. What would be my y-axis label on this graph? Good. Not just consumption, but the residual of consumption. So how much was off from what was expected to happen? All right. And then your income. Okay, and you're going to find the squares regression line, the correlation coefficient, that's your R value. R doesn't mean residual. R means your correlation coefficient. And then, before you get started, now let's come down here and take a look at this. The next section says, create a graph of temperature as the explanatory variable. And consumption is still the response. So see, the first time you're using income. The second time, temperature is your X value. And so ultimately, what I think this exercise is wondering is, what do you think, before we even get started, what do you think will be a better predictor of your consumption? Your income or the temperature? Yeah? Okay, well, we'll see. We're going to see. So that's kind of what we're wondering. What's a better predictor? Income or temperature on your ice cream consumption? Okay? So just be careful what it says. There is one typo here on this letter H. This is not supposed to be income written right here. This is supposed to be temperature because this problem was about temperature, not income. So that was a typo. I think most everybody kind of followed that. Okay. And then one last word of warning on this page 14. Make sure you are mindful of which equation you use. So watch which equation to use. Do you use the income equation or do you use the temperature equation? All right? So just be mindful of which equation to use. All right, those are all my hints to you on this assignment. So let me go ahead and let you guys get started on that. I'll walk around getting any of your calculator questions.